Okay. So this is also example from past year paper lah, quite recent. The wall shear stress tau in a boundary layer depends on the distance from the leading edge of the body x, okay, the distance, the density rho, the dynamic viscosity mu of the fluid, and the free stream velocity v. Using the method of repeating variables and the Buckingham's pi theorem, determine an expression of wall shear stress tau in dimensionless form. Take x, rho, and v as the repeating variables. So in this question, they already given you the repeating variables that you need to use. Okay, and they give you unit for shear stress tau is Newton meter minus 2. Okay, so this is 12 mark. Banyak Okay. So now, I hope you still remember the 6 step the 6 step how you used to solve this question lah. Okay, the first one is that you list all of the parameters kan. List all the parameters. Okay, and they said tau is a function of, okay, depend on, okay, function of lah. Okay, the first one is the distance x, the density rho, the dynamic viscosity mu, the free stream velocity. Okay, so this is all the parameters in this question. Okay, so now my question to you, what is the value for n? Anyone? The value of n, the parameters.
4.
4. How you come with 4? Come up with 4. Is it this one? 1, 2, 3, 4. Okay. That's not right. You forgot about this parameter as well. Ini pun parameter jugalah. Don't forget the dependent. Don't forget count the dependent variable as well in your parameters lah. For your parameters, we include the dependent variable 1 and all this independent variable 3, 4, 5. Okay, so your n is 5 lah. 1, 2, 3, 4, 5. Okay, boleh?
Boleh sir.
Okay, so this is your dependent variable kan? Dependent variable kan? Dependent variable. Okay, because this is the tau that is depend on the x, the distance, the rho, the mu, and also the velocity. Okay, and this also the one of the parameters lah. Okay, the tau pun sekali lah dependent variable, and this is the independent variable. The other ni independent variable lah, x, rho, whatever. Okay, so your n is 5. 1, 2, 3, 4, 5. F ni function it's not a parameter, it's just a function of this tau is a function of x, rho, mu, and v. Okay, that's your first step. Okay, the second step is list your second step. Siapa masih ingat? List the
primary dimension.
Primary dimension. Good, well done. So the second step is list the primary dimension for all of these parameters lah. The primary dimension, you have the 7 kan, 7 primary dimension. But normally the common use is the MLT lah. M, L, and T kan. The mass, the length, and the time. Yang lagi 4 tu yang amount of light, amount of matter, mole, temperature, itu very rare that you will find. Normally we use this lah, this MLT. Okay, so easy to remember, the second step is to list the MLT for your parameters. or list the primary dimension. Okay, so you have 5 parameters. So normally my suggestion, you draw a table for all those parameters, tau, x, rho, mu, and v. Okay, and list down this primary dimension for all of these parameters. Okay, for the first one, the tau. So they give to you the unit for tau. The shear stress is Newton meter minus 2. Newton meter minus 2. So who can come up with to me what is the primary dimension for tau in MLT? Siapa boleh ni bagi jawapan the primary dimension for tau? Boleh? Siapa-siapa nak cuba, just cuba je, or you can do on your paper and then just give me the answer, the MLT for tau. Ini unit dia, Newton meter minus 2. Anyone?
ML negative 2.
ML negative 2. ML negative 2. So how you get this? Can you explain?
Sir, saya nak cuba sir.
Boleh.
ML
ML
3 power of negative 3.
Macam mana? ML 3
ML T
T
T power of negative 3.
negative 3. Okay. Anyone want to try? I still did not get the right answer, but it's okay. Just try. Anyone else want to try? Okay, tadi yang apa, ML minus 2, how you get this? How you get ML negative 2? Tadi ni, yang second, ML 3 minus 3, how you get that? Siapa cakap ni? Saya tak sure siapa cakap.
Sir, yang apa? ML T power of negative 6
6? Bukan?
Bukan.
It's okay. Just try. But how you want to find the primary dimension? Is from the unit kan? Betul. How you get this? MLT minus 6? Okay, the unit of tau is Newton meter minus 2. Betul? Because it gives to you here, Newton meter minus 2. Okay. So Newton is apa? Newton ni unit untuk apa? Force.
Force.
Okay, force. And what is force?
MA.
MA. And what is MA? M is the mass, Okay, M. A is acceleration. And what is for primary dimension for A? Acceleration? Acceleration is
negative
LT negative 2.
LT negative 2.
Okay, so you have M L T negative 2 for F, for F kan, which is the Newton lah. And now you have meter minus 2. Meter ni length lah kan? Meter length lah kan? Tak ada lain lah. It's not ni meter ni bukannya mass Meter ni unit for length kan? Betul? Ni Newton meter minus 2 ni. So, meter minus 2 ni meter length lah, length minus 2 kan? Which is L apa for Newton meter minus 2. So it will be meter, you have find for F MLT minus 2, and you have another meter minus 2 which is L minus 2 kan? Betul? Betul tak?
Betul sir.
So now tell me what is the final primary dimension for tau?
MLT negative 4.
Ni mana? Ni L ni. Bukan T, salah.
Oh,
ML, okay, L negative apa?
Negative 1.
Negative
negative
1.
1. T
T
negative 2.
negative 2. So this is the primary dimension for tau, kan? So this is wrong. Is wrong. So the right answer is M1. M1 So M1 L minus 1 T minus 2. Okay. So be careful with the primary dimension. Is actually it's easy. When I show you, you know how to do it, kan? Ask you the Newton F, kan? You know MA and you know the primary dimension for F, and then you just multiply with the L minus 2, kan? The meter minus 2. So you know how to get this. You just need to be careful lah. Newton meter, and then you need to you need to open up lah. You need to break this unit. Unit for Newton apa, and meter minus 2 apa, kan? So you get the primary dimension for tau is M1 L minus 1 T minus 2. Okay, boleh faham ni? How you get the primary dimension? Okay.
Boleh sir.
How about the X? What's the primary dimension for X? The distance. X.
L.
L lah. It's just L lah, kan? L1 lah. Okay. It's easy, How about the row? The density.
M
Betul.
L negative
L.
3.
Yes.
L negative 3.
Betul. Correct lah. Betul. Because mass density, mass over volume, kan? Volume length cube lah. Okay. So that's why you have M 1 L minus 3. How about the mu? Ni another thing that is quite difficult lah. The mu is viscosity. Apa itu viscosity? That's why the paling tricky dalam chapter 5 ni is about to know what is the equation for that parameters. Viscosity, apa dia punya equation? Force, apa dia punya equation? Density, apa dia punya equation? Velocity, apa dia punya equation? Then you can know what is the primary dimension. Okay, now the dynamic viscosity, what is the equation for the dynamic viscosity?
M1
M1
L negatif 1 T negatif 1.
L negatif 1 T negatif 1. Right, you are correct. Okay, how you get this? From the equation lah, betul? How you get this M1 L minus 1 T minus 1? Is this correct? The primary dimension. Just for the sake of learning to the others, how you get this? Siapa? Saya juga ni. Hello?
Apis sir.
Apis. How you get the primary dimension for viscosity?
Tak saya.
Apa? Tak ada. Dynamic viscosity, you know, is about Pascal times the T, kan? Pascal times second. Okay. If you do this, you know Pascal is pressure, is force over area. So you can find that unit the primary dimension for force over area, and then multiply with time, second time lah for time. So you will get this lah, M1 L minus 1 T minus 1. Okay. So this is the trickiest parameter lah. To solve the question, if you fail to do this, if you do it wrongly, this MLT, it will affect your the other step, the step 4, 5. You want to generate your pi, so you will have a problem lah at that step. That's why this second step you need to do it carefully. Okay, do it calmly, don't rush, and find the equation for the viscosity and find the primary dimension. Okay. Okay, the fifth one, the velocity. What is the primary dimension for velocity? Apa for velocity?
L negatif 1.
L bagaimana?
M
L
L negatif 1.
negatif 1. Are you sure with that?
M1.
M1. No.
MT.
MT ni satu.
Apa
Sorry sir.
MT.
MT.
MT negatif 1.
Are you sure? Again, I asking you. Are you sure with this? Velocity.
Oh, okay.
Velocity.
L. LT negatif 1.
So that's why I said you know that already, but it's just a very careless, So you know velocity is distance over time kan, or s over if I'm not sure what symbol you use, but distance over time lah. So distance or s is length lah kan, length, and t is t lah. That's why you have L t minus 1. Okay, so that's why I say careful with this step. The second step ni paling penting, the crucial step. If you get the second step wrong, your answer after that will also be wrong. Okay, so be careful with this step lah, the second step. Okay, boleh faham semua
Boleh ke?
Okay, maybe I think you careful because you need velocity ms minus 1 kan. Is it because of that? So that's why you wrote m here, ml minus 1 or mt minus 1. So again, the unit ni m ni is not the mass, it's a meter kan, meter per second. So that's why it's length lah, length per time lah. Okay, remember the primary dimension, the m ni is a mass, okay, not meter. The l ni length and t is time. Okay, I think there is a table given to you in this note. Mana ada? Rasanya ada rasanya. This one So all of the quantity with the primary dimension, the m, lt, lt. But this is not given to you in the exam. Okay, this table is not given to you. That's why you need to understand how you can find the primary dimension for this quantity lah, velocity, force, density, and whatever lah, viscosity, everything. Okay. Okay, any problem with that second step?
No sir.
Tak ada Okay, now the third step. Thank you to next page. So the third step is finding your number of pi. Calculate number of pi that you will generate. Okay, using this equation k equal to n minus j. K ni number of pi lah that you want to calculate. Okay, n is 5. Okay, you already mentioned here n is 5. Okay, so now 5 minus j. So tell me what is the value for j? What's the value for j? Anyone? Apa nilai untuk j? Or what is j?
Tiga sir.
Yes, correct. How you get 3? How you get 3?
Repeating variable.
Repeating variable. Maksud awak ni ke x, rho and v ni?
repeating dimension.
Ini yang MLT ni. J ni is the number of the primary dimension lah. Okay. And in your parameters here, so you have M, L and T. So that's 3 primary dimension. Okay. So let's say when you do this second step, you only have M and L. Let's say. Okay. For example, an other question, and when you done the second step, the primary dimension in all your in the parameters only have M and L. Okay, so your J number is berapa nilai J kalau macam tu? Berapa kalau ada M dan L je?
2.
2 lah. Okay, in this question you have 3. Ada M, ada L dan ada T. So your J will be 3. Okay, boleh faham So J is 3. Okay, so your number of pi or K will be 2 lah. Okay, 5 minus 3 will be 2. Okay, so that means you will have 2 pi's or 2 dimensionless parameters that you will need to generate in this question. So now you know that you have 2 pi, okay, or 2 non-repeating. Okay, dimensionless ni non-dimensional and non-repeating. Okay, so step number 4. So now the step number 4 apa? How to choose choose repeating variables. Choose repeating variables or parameters. I explained to you before how we can choose these repeating variables according to this guideline kan? Remember this guideline for step 4?
Yes, sir.
Can? Okay, because in this question, they already give to you take X, rho and V as the repeating variables. So it is lah your calculation. They already ask you to take these 3 as your repeating variables. So you don't need to find that by yourself. You don't need to refer the guidelines to choose the repeating variables. It's already given to you. Okay, so your repeating variable will be X, rho and V lah. Okay, because it's given to you. Okay, now so you have X, rho and V ni as your repeating variable. So you will left to you tau and mu as your non-repeating variables. Okay, so you will use that lah in your to generate your pi. Okay, so your first pi. Okay, now you generate the fifth step is generate the pi. Generate pi. So you have 2 pi. So pi 1 and pi 2. So pi 1. So you will have the non-repeating variable for the first one is tau lah. Okay, tau. Function of this repeating variable X. Okay, A1. Sorry. Salah formula pula. Okay, so X A1, rho B1 and V C1. Okay, the exponential for each of these parameters. Okay, and pi 2 is, can someone tell me what is for the pi 2? Now you have used your tau, and the next one is apa the next one for second pi?
Mu.
Mu. Okay, good, thank you. So mu, okay, X or your repeating variable. So X A2, rho B2, V C2. Okay, so this is your 2 pi that you will generate, and you want to find this number, this exponential lah. Okay, so you will find the A, B and C, A1, B1, C1 and also A2, B2 and C2. Okay, so this will be your, so this part is your repeating variable kan. So this is your repeating variable, and this part, the tau and the mu, okay, this is your, this is the non-repeating variable. Okay, non-repeating variable, and this pi that you want to generate lah, the dimensionless parameters. Okay, so this is the non-dimensional parameter or dimensionless parameter. Okay, that you want to find. Dimensionless, dia takkan ada dimension lah. That's why we call dimensionless. Dimensionless parameter. Okay. Now you solve it one by one. Okay, because this is apa? Okay, let's say for apa? For the pi 1 first. Pi 1 equal to tau x a1 rho b1 v c1. Okay, because we know pi 1 is the dimensionless parameters, so the dimension will be m0 l0 t0 lah. Because it's dimensionless kan. Okay, and the tau, we know the primary dimension for tau is m1 l minus 1 t minus 2. Okay, m1 L minus 1 T minus 2. Okay, so this is the for tau, and then you have for x, so x is L kan, L1. So remember to write also number 1 on each of the parameters, A1, and rho, so you have rho, apa rho tadi, M1 L minus 3. So M1 L minus 3 for rho, so this is B1, and for velocity N1 T minus 1 C1. Okay, now you will solve the exponential equation for each primary dimension for M, L and T. So we do one by one for M. Okay, for M, so 0, okay, 0 equal to 0 equal to M1 1 plus ni tak ada, plus 0 lah, plus 0 plus this one M1 times B1, so you will have plus B1, and this one tak ada M juga, so 0 lah, so you will have B1 equal to minus 1. Okay, it's easy. The second primary dimension is for L. So again, L 0. Okay, 0 will equal to. So we have 1 minus 1 plus we have L times A1. So A1 plus this one L minus 3 times B1. So will be minus 3b1 plus we have L1 times C1, so we will have plus C1. Okay, so we have two unknown, so that we cannot solve it yet, but we know B1 is minus 1, so we need to find for C. So we do for T first before we solve for L. So for T, again the same thing that you need to do. T0 equal to minus 2 plus ni tak ada T, ni tak ada T, ni ada T, minus 1 times C1, we will have minus C1, and this will give us C1 will equal to minus 2. Okay, so we know B1 is equal to minus 1, C1 minus 2, so now we can solve for A1 lah. So 0 will be minus 1 plus A1 minus 3 times B1. B1 is minus 1, so minus times minus is plus lah, so we will plus 3 plus C1. C1 is minus 2, so it will be minus 2. So A1 will be equal to 1 minus 3 plus 2. So this 1 minus 3 is minus 2 plus 2, this will be equal to 0. Okay, boleh faham ni how you solve this equation, this exponential equation?
Boleh ke?
Faham
Okay.
sir.
Okay, if you not understand, just ask me. Okay, we can discuss it. I will explain it again. Okay, now we have number for A1, the exponential number lah for A1, B1 and C1. Now we can write our pi 1 will equal to tau. So x A1, so x A1 A is 0, so x 0. Rho B1 is minus 1, so rho minus 1, and V C1 is minus 2, so V minus 2. Or we can write it again in equation form. Sorry. Okay. So pi 1 will be equal to tau over at 0, tak ada 0, tak ada je lah over rho, because rho minus 1 over rho and over v kan, v squared v minus 2, so v over v squared. So this is pi 1. Okay, so you have 2 pi, so you need to do for this one for the second pi. Okay, do the same. So for pi 2, so we know pi 2 equal to mu times x rho and v x a2 rho b2 vc2. Okay, again buat macam tadi lah equation for MLT. So pi 2 ni dimensionless, so that's why you have M0 L0 T0, and we know the dimension for mu is apa tadi kita buat, mu is M1 L minus 1 T minus 1. Okay, so N1 L L minus 1 ke 1? Betul dah. L minus 1. Okay. L minus 1 T minus 1 for mu. And then we have X L1. Okay, A2. And we have rho M1 L minus 3 B2. And we have V L1 T minus 1 C2. Okay, again solve the equation for the exponential equation ni. So for M, okay, for M 0 equal to 1, ni tak ada, plus 0 plus this one 1 times B2, so you have 1 B2 and ni tak ada, so ni 0, so we have B2 will equal to minus 1. And then for L, okay, 0 L equal to L ada 1 minus 1 plus ada A2 ada 1 L, so plus A2 plus kat sini ada 1 minus 3 times B2, so 3 minus 3 B2, and kat sini ada satu lagi 1 times C2, so plus C2. We have 2 unknown again, so we need to solve for T first. So for T 0 equal to, okay, 0T minus 1, okay, ni tak ada T, ni ada T minus 1 times C2, so minus C2, so we know C2 will equal to minus 1. Okay, now we can solve for the L. Okay, we know C minus 1, so 0 will be equal to minus 1 plus A2, so B2 is minus 1, so minus 3 times minus 1 will be plus lah, will be plus 3, and plus C2 is minus 1, so minus 1. So we will have A2 will equal to 1 minus 3 plus 1. So this will equal to 1 minus 3 minus 2. Minus 2 plus 1 will be minus 1. So your A2 will be minus 1. So you have A2 and you have B2 and you have C2. Now you can solve your equation for pi 2 will be equal to mu times x A2. A2 is minus 1. Okay, rho B2 is minus 1 as well. And V C2 pun minus 1 juga. So V minus 1. So you can write your final version equation for pi 2 will be equal to mu over x rho and V. Pi minus 1 kan. Okay. Now you already solve your 2 pi's. Okay, you got your pi 2. Okay, ini equation dia. And you also got your pi 1. Ini equation dia. So the sixth step is the last step. The sixth step, write your pi equation. Write your pi equation. Okay, we know to write the pi equation. Pi 1 will be equal to a function of pi 2 lah. Okay, if you have 2 pi. If you have 3 pi, so this will be pi 1 equal to function of pi 2, pi 3 and pi 4 or whatever lah. Depends on how many pi you have. Okay, so in this equation you only have 2 kan, 2 pi. Okay, so that will be your equation will be pi 1 a function of pi 2 lah, macam ni. Okay, so you will write again your pi 1 and pi 2. So your pi 1 is tau over rho v squared. Okay, so tau over rho v squared. This will be equal to f function of pi 2, and your pi 2 is mu over x rho v. Okay, and to get your final equation for tau, okay, this will be bring this this term to the other side lah. Okay, so you will have rho v squared f mu over x rho v. So this will be your final answer for tau. Boleh? Any question? Any question?
Boleh sir.
Boleh
No question.
No question. Anyone else? Ada soalan? Ada yang tak faham? Tak ada Okay, I hope you understand lah. Okay, but you don't have any question, so I hope you understand how to solve this question. Okay, determine an expression of wall shear stress in dimensionless form. Okay, they give you the repeating variables, and you need to do this 6 step lah, and you will get 12 mark. Okay, easily 12 mark for you. Okay. Okay, I show you another one. Okay, and then we can end our class lah. Okay, example 2. This is quite easy, I think. So the power P required to drive a fan is a function of fan diameter D, the fluid density rho, the rotational speed W, and the flow rate Q. I'm not sure apa kita panggilnya kalau W ni, angle rotational speed ni. Apa? Siapa tahu? Bukan W kan dia panggil?
Omega kan?
Apa?
Omega.
Omega. Okay, thank you. Omega and the flow rate Q. Using the dimensional analysis by Beckham's pi method or theorem, write the general expression for F. Okay, who can do this? The first one. The first step. If you this question A ni jawapan untuk ni lah yang first step. Apa awak buat mula sekali? Write your all parameters tu. How you write that? Anyone? The power P is function of diameter rho
P
P, okay,
equal to
equal to
function uh, in bracket
in bracket
D
D,
rho
okay, rho
omega and
omega
Q.
and Q. Sorry. And last one is Q1. Okay. So that's how lah you write the general expression for this F. Okay. So power, it says here in the question, the power required to drive a fan, okay, is function of diameter, fluid density, the rotational speed omega, and also the flow rate. So now let me ask again, what's the value for n? Number of n, number of parameters.
5.
5. Okay, so you have 1, 2, 3, 4, and 5. Okay, well done. Thank you. And it says you show that the dimensionless groups expected to be formed from the variables are pi 1 P over rho D kuasa 5 omega kuasa 3 and pi 2 Q over D kuasa 3 times omega. Okay, you need to show this. Okay, how you want to do this? How you can show that?
This primary dimension.
Okay, okay, good. Primary dimension. Okay, we know when you write the primary dimension. Okay, pi 1 will be m0, l0, t0. Okay, so this will be equal to this P. Okay, P apa? Power. Apa? What's the primary dimension for power? Siapa boleh bagi tahu? Macam mana? For P. Power apa power? What is
Power is energy over time.
energy over time. Okay, good. Power is energy over time. Okay, betul. Watt n. Okay, how you want to translate this equation into the primary dimension? Energy apa pula? Apa pula untuk energy?
Energy is same with work.
Okay, work,
Work equal to force
force,
times distance.
distance. FD lah. Okay. So now you know
FD.
for F apa? Force,
FMA.
MA. Okay. What is the
MA.
primary dimension for force? MA tadi. Okay, F sama MA saya buat satu. Okay, F sama MA. Okay.
The
F jadi
dimension is M
M
L
L
T negative 2.
negative 2. So that is your F, N. And D,
And
apa?
D is L.
L. So if you times another L will be L squared lah.
L square.
And for energy kan.
Yep.
So ml squared T minus 2. So that's for energy. You know you want power. Tak habis lagi ni.
Yes. The time. Time
apa?
is T.
Over time lagi kan. Over T. So
Over T.
final version apa jadi untuk power is M
M L
L L apa?
L power of 2.
2. Okay, M L2
L2 T negative 3.
negative 3. Okay, so this is primary dimension for power lah. Okay. you know this, you know how to do this. Okay, just you need to do by step lah, power apa. Okay, then you can find that. Okay, now we know for power M1 L3 L2, sorry. So M1 L2 T minus 3. Okay, that's for power kan. Okay, and we have power and we have rho. What is for rho? Rho tadi dah buat tadi. L pula M kan. Okay, so for L M1 L minus 3. Good. And we have distance. Okay, distance is L1, and we have this omega speed. Okay, speed is apa for speed? L speed L T minus 1 L1 T minus 1. Okay, so that is ni lah untuk rho, diameter and apa rotational speed. Okay, so now we find to prove that apa this pi 1 is equal to P over rho D kuasa 5 omega kuasa 3 so we need to prove that. Okay, you need to find lah, so we need to find this repeating variable rho D and omega ni. So we need to find the the exponential number for this repeating variable. So we can, you need to find, so D tu maksudnya 5, omega tu 3. So we can prove this pi 1 and pi 2 kan. Okay, we need to do again lah apa step by step. Okay, for pi 1. Okay, so we have it means that we will take rho D and omega as our non-repeating variable kan. Okay, in the second in the fourth step. Okay, choose repeating variable. Okay, because it gives to you this dimensionless group have rho D and omega. That means we have 3 non-repeating variables, rho D and omega, and P and Q ni will be our non-repeating variable. That's why you have rho over something or Q over something for pi. Okay, you get that? Boleh Okay,
boleh,
now,
sir.
okay, boleh. Now we do one by one. So for pi 1, okay, for pi 1, so this will be P times the rho, the repeating variables rho D and omega lah. Okay, betul? So A1, A1, B1 and C1. Okay, so now that can do on kat sini lah, baru jelas sikit. So pi 1 equal to P tadi apa, rho A1, okay, as D B1 and omega C1. Okay, and this one will be M0 L0 T0, and for power tadi apa M1 L2 T minus 3 M1 L2 T minus 3 for power, and for rho is M1 L minus 3. So this A1, and D, the diameter is L lah. So length kan, L1 times B1, and omega, the speed, L1 T minus 1 for C1. Now we solve one by one for M. Okay, 0 equal to M1 plus 1 times A1, so plus A1, tak ada, so M, the A1 will be equal to minus 1. Okay, and then do for L 0 equal to 2, okay, plus minus 3 times A1, so minus 3 A1, and we have B1, 1 times B1 plus B1, and C1, so you have 1 plus C1 plus C1. You have two unknown, so you cannot solve it yet. So you do for T, so for T 0 equal to minus 3 plus tak ada T plus minus C1, so minus C1, so C1 will be equal to minus 3. Okay, so now you know C1 is minus 3, you can solve for A, so A 2 minus 3 A, so you can solve for B, sorry, so 3 minus, sorry, pada balik. Okay, 2 minus 3 times minus 1, so this will be plus lah, plus 3, okay, plus B1, and C1 is equal to minus 3, so you will get B1 equal to minus 2 minus 3 plus 3, B1 minus 2 minus 3 plus 3, so this will be minus 2 minus 3 minus 5, minus 5 plus 3 will be minus 5 plus 3 minus 2. Okay, so you will get B1 equal to minus 2, so you will have your pi 1 equal to P times rho A1 is minus 1, D B1 is minus 2, and omega is C1 minus 3. So you will get pi 1 equal to P over rho 1 D2 omega 3. Okay, so in this question, dia got D5 D5, maksudnya ada salah sikit lah, saya salah, the M0 L0 T0, D ni dapat 5 B1 ni 5, so can we check again? So for L0 equal to 2 minus 3A1 plus B1 plus C1, okay, 0 2 plus A1 is equal to, this is minus 1, so will be plus 3, B1 is B1 and plus C1 is 3, okay, so minus 3, so B1 equal to minus 2 minus 3 plus 3, I got minus 2, macam mana dapat ni 5? Can someone M0 L0 T0 M1 L2 T minus 3 L1, oh, okay, I know where is wrong. Siapa boleh point out where is my mistake? Siapa boleh jumpa? Anyone?
So salah tolak
Bukan, salah primary dimension salah. Kat mana, apa yang salah primary dimension saya? Okay, row, you got row M1 M-3, okay, this is correct. L, diameter is L, betul, L1. This one, rotational speed ni. Apa unit for rotational speed yang sepatutnya? Apa? Anyone can Give to me.
In second.
Apa?
Radian per second.
Radian per second. Betul? Kan? It's not meter per second kan? It's radian per second. And so this is only T minus 1 je. It's not L1 T minus 1. So this is the mistake. So they give you the rotational speed, not the speed, not the angular speed, not the linear speed. Sorry, this is rotational speed. Okay, yang that's why it's omega, and omega is T minus 1 per second je, radians per second kan. Betul tak?
Betul sir.
Okay, so that is the mistake. Okay, so this one should be only T minus 1. Okay, so T minus 1, so I have again 0 for T 0 maksudnya salah dekat ni lah yang L ni tak ada. Okay, kat mana saya guna L for L lah, for L. Okay, for L 0, okay, 2 minus 3A1 plus B1 plus tak ada sini tak ada kan, betul tak? Tak ada ni tak ada C1 because we don't have L here. So that's why so we can cancel out this 3. Okay, it's only 2 minus 3A1 plus B1. So we know A1 is minus 1, so 2 plus 3 plus B1. So that's why we will have B1 will be equal to minus 2 minus 3, so it will be minus 5. So then we can prove that the pi 1 will be equal to power over rho d5 omega 3 power of 3. So it's same lah with this one. Betul tak? Can you get that? Boleh?
Boleh sir.
Okay. And now do the same for pi 2. Okay. For pi 2, okay, for pi 2, yes ni, for pi 2, so we will have pi 2 the Q lah, Q times rho d and omega. Do the same lah for this one, like this one for Q2. So you have rho A2 diameter B2 omega C2. Okay, again this is dimensionless parameters for pi, so that's why we have ML M0 L0 T0, and we have Q is flow rate. Okay, Q is flow rate. So what is the primary dimension for flow rate? Anyone? Flow rate. Apa primary dimension? Apa flow rate? Flow rate. Apa dia punya ni? Primary dimension for flow rate. Apa yang flow rate? Apa tak dengar? VA. VA. Apa VA? Oh, yang tu apa? That volume flow rate. No, bukan yang tu, bukan yang that apa, not that Q. Flow volume flow rate lah, bro. Apa that's the equation lah, apa yang VA kan, A the apa times V kan. The apa, the continuity equation kan, volume flow rate. Betul lah, betul lah awak cakap. Okay, A times V. Okay, the A, apa A? Area kan?
Area.
Okay, what is area? Primary dimension for area?
L
square.
S square lah. Okay, and for V? Velocity.
L
L
T negative 1.
T negative 1. So if you combine this, the primary dimension for Q, the volume flow rate is
L cube
L cube
T
T
minus 1.
minus 1. Okay, so you get that for flow rate. Okay, so now for Q, L3 T minus 1. Okay, thank you tadi siapa yang bagi saya pun terlupa lah. QAV. Okay, and now rho, again rho is M1 L minus 3, M1 L minus 3, A2, and D L1, B2, and apa omega T minus 1, C2. Okay, do again the same for M L and T. So for M, L0 equal to tak ada M, ni ada satu M, A2, tak ada lah, so A2 is 0 lah. Okay, and then for L, so 0 equal to L3, 3 ni plus minus 3 times A2, so minus 3A2 plus B2 and kosong, tak ada. So we have A2 kosong, so B2 will be minus 3 lah kan, minus 3. And then for T, we do again the same, 0 will be minus 1 and minus C2. So we will have C2 equal to minus 1. Okay, and now we can write our pi 2. Okay, pi 2 mana? Pi 2, oh ni pi 2 will be equal to Q over A2 0, so tak adalah, and B2 is minus 3, so D Q, and omega C2 is minus 1, so over D cube over omega times omega, so it will be the same lah for this one kan. Now you show lah, betul tak? Boleh? Faham? How you get this?
Boleh je.
Boleh okay, now you prove that pi 1 and pi 2. Okay, now the last question they ask you, show that the dimensional analysis yields an expression for f as this one. So this is only pi 1 equal to f times pi 2 kan. So you write again lah, pi 1 is your pi 1 kat sini awak dah buktikan tadi P over this one, P over rho D kuasa 5 omega kuasa 3. Okay, so you can write again P over P not rho, P over rho D kuasa 5 omega kuasa 3 function of pi 2, and pi 2 is here Q D over cube D cube over times omega, so Q over D cube times omega. So now you prove it, you show that. Okay, any question? Is it difficult? Is it difficult, this chapter 5?
A little bit.
A little bit. The myth is chapter 5 ni paling senang. Bukan the myth, the truth. Sorry, the myth lah. And the truth is chapter 5 ni the easiest chapter in this subject. Subject fluid mechanics. Chapter 5 ni lah yang paling senang sekali. Okay. Compared to other chapter lah, chapter 3, 4. So you need to score this chapter, okay, because it's very free mark lah for you. But again, like as I mentioned to you, the trickiest and the paling crucial, how you need to be very careful to write your primary dimension for all of these parameters. Tadi pun saya dah silap pasal rotational speed kan. speed ni kan through speed kan, but again is a rotational speed not the linear speed. Okay, so that's why they give you the omega, not the v kan, the normal velocity to v kan. Okay, so you need to be careful with that. If you wrong in that second step, list your primary dimension, it will affect everything. Then to generate your pi akan salah, and then you cannot prove, you cannot write your final version of the dimension, this parameters lah, because you make a mistake in your second step. So my advice, when you want to do this question, please focus on the second step and the list yang step bila kita buat primary dimension ni, this step. Okay, this step is very crucial lah. Okay, you need to very careful remember what is tau, what is they give you the Newton meter -2, so you need to be careful what is the primary dimension for Newton and what is the dimension for meter. So that's how you can solve the question dengan betul lah. Okay, alright, any more question or anything before I end the class? Tak ada?
No.
Okay. Also given in the notes, okay, you can refer to the notes, the quantity for all the parameters here, sini. This is very common lah, and the common parameters velocity, acceleration, force, energy, power, pressure, density, specific weight, density, ni relative density not density, viscosity. So this is given to you in this note. You can refer to this note, but in the exam we're not given this one lah. Okay, this one is for only for learning purpose, not for use in the exam. So that's why you need to understand how you can find the primary dimension for each of this quantity. Okay, alright. For our next class, this Tuesday, okay, because we cover everything, okay, every chapter we have covered. My plan is that we will do the asynchronous class. Okay, I think you familiar with that. So we will not having the live class. Okay, I will post to you the tutorial for chapter 3. We have 3 more class kan this Tuesday, and the next week 14 we have another 2 class. So my plan is to cover chapter by chapter lah. Okay, you have 3 chapter kan that will come to the exam, chapter 3, 4 and 5. So this Tuesday, so you will be doing all the tutorial for chapter 3. Okay, I have posted in the Google Classroom the materials, so you can do that. Okay, so we don't need to have this live session. Do it at your own pace. Okay, and then just mark your attendance, just fill out the attendance form for your record. And the next week, okay, in week 14, another 2 class, we will doing the chapter 4 for the first one, for Sunday, and Tuesday we will doing again the chapter 5, so that we recap back lah the chapter 3, 4 and 5, the tutorial again. Okay, can we do that?
Yes, sir.
Okay, but if you have a problem, just let me know. You can text me from the WhatsApp group, or you can PM me. You can ask me any question lah if you have a problem. And if you really want to have require the live session, you want me to explain to you again, you can just tell me and we can meet up at that allocated time lah, not the other time that at your class time too. If you really need help, you really need explanation, I'm available, and we can do this live meeting lah for anyone who feel that they need the explanation again. Okay, So that's all for today. Thank you for your attendance. Don't forget to fill in the attendance form. We will meet again. No, we will not meet again. Okay, we will meet again in asynchronous class lah. This Tuesday, asynchronous class. I've posted the material for you in the Google Classroom. Okay, with that I end the class. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.